Hi, this is Kurt.
And this is Jacob. We are Cornell students in CS 4701, Introduction to Artificial Intelligence Practicum, and we have made KNIA the Scrabble know-it-all. The project was to design a artificial intelligence to do any task. We decided word game because we love playing word games. We hadn't heard a lot about Scrabble and AI, but it's a difficult challenge because there's a lot of different moves you can do, but it's very easy to understand how to play, and we thought it was unique.
We also felt that the environment of Scrabble best emulated a human's environment, and we thought that would be an interesting agent to program. So, for example, Scrabble's environment involves a multi-agent one because you're playing against opponents, partially observable because you cannot see your opponent's hands, stochastic because when you play words, you draw new tiles randomly from a bag, and sequential because your moves build on each other to build up the word board.
We were able to speed up the process of building NIA a lot. We found an implementation of Scrabble online from a programmer named Steve Young. So thank you, Steve. He had a GUI all set up for us, and he also had he also had Wordsmith, which was his own AI, which only just calculated the best move per turn. Didn't look at any sort of stats or what the next move might be, or if they opened up a triple word, all that sort of things. And we really wanted to see how much better an AI could be with the strategies that we had learned in class.
So we thought, what sort of strategies should we use to implement NIA? Well, we knew that since this was an adversarial game, some version of minimax would be we would have to utilize. So we figured expect a minimax would be the best way to go because Scrabble involves the middle action of drawing tiles, which involves a stochastic process in the middle of the game tree. So then we decided, okay, how are we going to pick these random hands? Well, we used a Monte Carlo simulation to figure out what available racks were left in the tile bag given your hand and what was on the board. And then we realized that the state space of Scrabble is pretty large, actually. Given 225 squares and 100 tiles, there are roughly 10 to the 380 possible tile combinations. Even for 10 tiles on a board, to consider every possible move, you would have to look at a million possible moves. So how do we limit this search space? Well, we looked at heuristics. We developed our own heuristics, actually. We looked at the word score, the utility of your rack leave, which is the remaining letters after playing a word, and then the board structure after playing a word, too.
Okay. So our implementation, execute turn is kind of the main method. It calls the artificial intelligence, it calls NIA, and then plays whatever move she returns. Find max of best moves is basically a weighted evaluation of the M moves that NIA has chosen through her M local beam search. She uses the opponent's average score to a move, her average response to that move, so like her second move, and the leftover rack leave, in addition to the word score for each move that she made. She weights all of those and is able to return the best word that she makes. Make and evaluate words basically just generates all possible and valid words. It makes sure the word that you play is valid and that the crossword on the board is valid, and it will return the M best moves based on word score and rack leave. An eval NIA basically just evaluates NIA's game tree as explained in our documentation, about 3 plies deep, and is able to utilize the above functions. We were also able to paralyze NIA a lot because board computations of Scrabble, like evaluating two possible opponent hands, they're independent. So if you want to consider two possible moves, so you can consider them both at the same time, which is able to really speed up NIA tenfold. So for playing NIA, we did 4 matchups. We did humans versus Wordsmith, humans versus NIA, NIA versus Wordsmith, NIA versus NIA. So human versus Wordsmith, the original best move only AI that was put in the game. We played against ourselves and we barely beat it. Its lack of foresight led to it didn't really have any strategy, but it was able to make big words that we've never heard of. However, we used a bit of strategy and we were able to beat it. Very proud of ourselves. But however, then we played NIA afterwards, after we had finished implementing her, and she was much more adept at not leaving open any bonus squares like triple word scores or even like triple letter scores. And midway through the game, as you can see in the picture, she was ahead by over 100 points. It was much harder to keep up with her, and so we thought it was a great success that she was able to beat us so badly. And then we put her against Wordsmith, really hoping that she would beat Wordsmith too. And she ended up beating him by almost 200 points. She has every capability that he does, but she also has rack management, and she can never, she won't get stuck with bad hands, and she also has look ahead, so she was really able to beat Wordsmith. And then Nia versus Nia, we have a demo we'll show at the end of the video when she plays herself.
So at the end of this project, we thought, okay, what sort of things can we do in the future to improve NIA? Well, we felt that a large blocker to computation time was just selecting the words to begin with, given that the current implementation looks at every possible combination of letters. So we felt that if we were to implement a quicker word picker, it would allow us to speed up her game tree search and to search deeper in the tree. On that note, we also thought that we could parallelize more of the computation to again speed up NIA's evaluation phase so that we could go deeper in the search space, figure out more plies, etc. Another couple things we thought we could do was play NIA versus actual Scrabble masters and observe her and manually see what sort of mistakes is she making, and then try to correct for those in the algorithm, in our algorithms. And then finally, we also thought that we could play NIA versus herself to improve the heuristic evaluations, especially the parameters in those heuristics. All of these are in search of a deeper search space to make NIA a really better player. So conclusions, we felt that this helped us gain an in-depth knowledge of several of the strategies for building rational agents that we learned in class, specifically adversarial search methods. It also gave us exposure to developing heuristics, which involved a lot of trial and error, and testing NIA to find more optimal parameters for the heuristics. And it also exposed us to the limitations of search space when working on a personal computer. I mean, had we had an industrial-sized computer, some of these computations wouldn't have taken as fast. But in the end, even given our limited computing resources, we were still able to come up with a very intelligent AI for Scrabble, and we're very proud of what she can do and how she can play.
So this is Nia versus Nia. We sped this game up about 80 times for this video. The game was about 45 minutes long, and each player really had great board manipulation. They were never really able to achieve a move using more than one bonus square at a time. There's a lot of competition for the double move slots, but what we thought was interesting was that only one, I think, triple move slot even got used the whole game, or maybe 2 out of the 8 that there are. However, we really thought she played well. There was a lot of big words made, and we're really happy with the way Nia turned out. So this is Jacob.
This is Kurt.
And thank you for watching.